So 9.3, we're graphing our rational functions here. This is going to be example 2. Let's see if we can figure this stuff out. First of all, we've got our denominator. Denominator is not going to cancel with anything. Going back to our example back here, not canceling. Let me clean some of this up. So when we didn't cancel, we had an asymptote. So we're not canceling in this example, so we have an asymptote. Our asymptote is going to be, well, x plus 1 equals 0, so x equals negative 1. We have an asymptote where x equals negative 1. Okay, that drawn in. Now I can go start plugging in points and seeing what I come up with. So let me try a 0. This is my x and my y. If I plug a 0 in here, that's going to be 0 over 0 plus 1. That's 0 over 1, which is just 0. So I'm going to have the point 0, 0. I can't put in the point negative 1. I can put in the point negative 2. So when x is negative 2, that would be a negative 2. And negative 2 plus 1 would be a negative 1. So that's going to be a positive 2. So at negative 2, I'm going to be at positive 2. At negative 3, so I've got to figure out basically what's happening as I go negative or to the left, and what's happening positive to the right. So I'm doing my negative part first to the left. So negative 3, that's going to be a negative 3 over negative 3 plus 1 is negative 2. So that's a 3 halves. 3 halves is 1 and 1/2, so I am here. Let's plug in a negative 4. So that's going to be negative 4 over negative 3, which is 4/3. 4/3 is 1 and 1/3. And negative 5. Negative 5 would be negative 5 over negative 4. So that's going to be 5/4, and 5/4 is, I'll move my point up just a little bit here. Oops, come on. Move that point up a little bit so I can put another point here. Oops, wrong place. Put that one where it goes to. What happens if I go even further negative? Am I ever going to get past 1 on this graph? Can I make this ever get less than 1? Well, if I'm having x, and if I have x plus 1, if the bottom's always going to be 1 bigger than the top, I'm never actually going to touch 1 either. So it looks like I've kind of got an asymptote here. I'm going to get closer and closer and closer to that 1, but I'm never going to touch it. So then I want to look going the other direction. So let's try, I've done 0, so we can do 1. 1 would be 1 over 2, which is 1/2. So I'm at 1, I'm at 1/2. And then at 2, that would be 2 over 3. And 2 over 3 is 2/3. So at 2, I'm at 2/3. At 3, I'm going to be at 3/4. At 4, I'm going to be at 4/5. And again, I'm going to have this asymptote go in this direction also on this graph. And then you could look at like negative 1/2 if you wanted to keep going with this and see what happens at negative 1/2. That would be negative 1/2 over negative 1/2 plus 1. That would be negative 1/2 over 1/2, which would be equal to a negative 1. And you see I am going down there. I could try negative 3 halves. So that would be negative 3 halves, negative 3 halves plus 1. That would be negative 3 halves. And negative 3 halves plus 1 would be negative 1/2. Remember, when you divide, you flip and multiply, so it's negative 3 halves times negative 2 over 1. So this would be a positive 3. And if I go up and graph that, my positive 3 would be here. So if we sketch this graph in, you're going to see we're getting ever closer here, and we're going to get ever closer there. And same thing coming positive. Oops. Wrong part right there. Ever closer there. And you can keep testing points, more and more points, until you are satisfied that that is in fact what your graph's going to look like.